Hi friends, in this problem we have A, B, C, three distinct real numbers in geometric progression such that sum of these three is equal to x into b. B is one of these numbers only. Then what is this x? Can What is the range of this x? Where can this x lie? Right. If these three terms are in geometric progression, we can call them as A, AR, AR square, right? Common ratio R. Now, with the given condition, let us input these three values, right? A plus AR square equals XAR. That means AR square plus R into A minus XA or AX, A minus AX plus A equals 0, right? We can take A common in all of this. There is A, here this is A minus AX is A into 1 minus X plus this A is also there. So we can cancel this A. Right, if you simplify this, this becomes R square plus R into 1 minus X plus A equals 0. If you see this equation is a quadratic equation, right, in the form of x square, ax square plus bx plus c, right, R square plus R into something plus A equals 0. Right, this is a quadratic equation, right, and clearly this is in terms of R. Now, if this has to have a solution, if R has to be real, right, this has to be 0, that means that some R, it has to be 0, right? We have to find the solutions of this equation. If R is complex, then it doesn't hold, right? R means it's a common ratio of this geometric progression. Clearly, R has to be a real number, right? R is actually the root of this equation, right? If the root of this equation has to be a real number, it cannot be complex number. What does that mean? This in this equation, b square minus 4ac should be greater than or equal to 0, right? If it is less than 0, then R will become a complex number because this is a quadratic equation. Ax square plus bx plus c. This is in that form, right? And here, when x, the solution of this equation, R, should be a real number. So that means b square minus 4ac should be greater than or equal to 0. That means what is b here? 1 minus x. 1 minus x whole square minus 4 into a should be greater than or equal to 0. That means we expand this x square plus 1 minus 2x minus 4 should be greater than or equal to 0. That means x square minus 2x minus 3 should be greater than or equal to 0. We can write this as minus 3x plus x. Right, x square minus 3x plus x minus 3 should be greater than or equal to 0. If we factorize this, this becomes x minus 3 into x plus 1 should be greater than or equal to 0. Right. We have product of x minus 3 and x plus 1 should be greater than or equal to 0. That means x can be greater than this 3. Right. If x is greater than 3, x minus 3 is positive and x plus 1 will be positive. Right. Or x should be less than or equal to minus 1. It should be greater than or equal to 3 or less than or equal to minus 1. If it is x is less than or equal to minus 1, say for example minus 2, then this is also negative, this is also negative, the product will be positive. But if x is somewhere in between, then one of them is negative, one of them is positive. So for example, if we take x as 2, then x minus 3 is negative, x plus 1 is positive. This will not hold. So x either has to be on this side or before on or before minus 1 or on or after plus 3, right? So x should lie between minus infinity to minus 1 or 3 to infinity. Please notice the brackets. Minus infinity, we should put open bracket, and this is equality, there is equality. So we can put closed brackets at minus 1 and plus 3, right? What does that mean? X cannot lie between minus 1 and 3. What does that mean? The answer is 2 cannot be, x cannot be 2. Right, guys? Hope you understood this. This is a simple problem, right? We are just making a quadratic equation for which R is a solution. A quadratic equation in terms of R, right? And this equation has to become 0. If this has to become 0, a quadratic equation, for example, the equation is something like this, x-axis. Then if it is touching x-axis, let's say, so these two are the roots, right? These two are the roots. This is some quadratic equation, either this way or this way. If it has to touch, then these two are the roots. If it is touching, then these two are real numbers. Otherwise, If b square minus 4ac is less than 0, then the equation goes like this. It doesn't touch x-axis. It can go like this or it can go like this. Right? Whereas b square minus 4ac is greater than or equal to 0, then that means it is touching x-axis and there are real roots. Right? B square minus 4ac equal to 0 means both roots are same. That means it is touching x-axis at a single point. If it is greater than 0 means it is touching at two different points. Either the graph can be like this or it can be like this also. Then also it will touch two points. Whereas this graph, this one and this one, they are not touching x-axis. Right? So that means they don't have real roots. They have imaginary roots. Right? B square minus 4ac for these graphs will be less than 0. So they will not touch axis and they will have imaginary roots. But in this case, R we want a real number, right? We want a number on this number line, right? We don't want some imaginary number, right? 2 plus 3i, 3i minus 4i, such numbers we don't want. We want real numbers, right? Rational or irrational, whatever we want real numbers which can be there on this number line, right? So if this equation has to have a real root. That means b square minus 4ac should be greater than or equal to 0. The graph of this function should be somewhere like this or somewhere like this, touching x-axis at 2 points or at least 1 point like this. Right, guys? So very basics of quadratic equations we need to use apart from geometry progression relation. Hope you guys like this. Thank you.